So in today's lesson, we are going to go through solving quadratics equations by factorization. So in algebra, we already learned about how to factorize. Now we are going to look into quadratic equations. Okay, so first things first is to figure out what is quadratic equations. Well, quadratic equations is basically, it comes from the word quad. Quad means squared, right? That means that these equation, the highest power of x is going to be 2. Okay, now quadratics, if we were to graph quadratic equations, they will look like these things called parabolas. So I've drawn it here. Yeah, something like that. Yeah, in terms of the shape. Quadratic equations are in this particular form. I think it'll be best for you to write this down because you might need to use it in the next few lessons. In the form of ax squared plus bx plus c equals to 0, which you guys should have already seen this type of form in your questions in algebra when you're factorizing, but this is particularly for quadratic equations. Now, quadratic equations, we can have 0, 1, or 2 solutions. Okay, that part there is really important. Let me just underline it. Okay, so quadratic equations, once again, can have 0, 1, or 2 solutions. Now, when we are solving quadratic equations, we are going to use this skill called the null factor. Now, null factor is basically if a and b is equal to 0, then a or b will equal to 0. Okay, so you could go a equal to 0, b or b equal to 0. I'll explain how the null factor kind of works in the example. It'll make more sense. All right, so first off, before we go to our example, recap on factorization, because this part here, if you do not know what methods of factorization you need to use, you need to have a little recap and a little review again. The first method is HCF, highest common factor. Second thing is PSF, product sum factor. Third thing is grouping in pairs. Now, grouping in pairs is only for non-monics, okay? Non-monics, remember, it is basically the number in front of the x squared, right? The coefficient is greater than 1. And lastly, difference between two squares. I've written down the formula down here. Okay, if you'd like to write that down, up to you. That's a recap on methods of factorization. Let's go. Example number 1. Solve the following equations. Okay, the first one is 4x squared equals to 5. Now, equations has everything to do with doing the opposite of things, right? And finding what x or y or whatever letter is equal to. So I know that my goal is going to be x equal to something. Now, to get me closer, I need to get rid of that 4, right? Between 4 and x squared, there's an invisible multiplication. To get rid of that 4, I need to divide by 4 on both sides to make sure it's balanced. 4 divided by 4 gives me 1. I'm now left with x squared on the left-hand side equal to 5 over 4. Okay, now x squared going to x. How do I get rid of that x squared? Do the opposite, which is square root. I'll square root on both sides, sorry. Okay, this squared and this square root will cancel out. I'm left with x equaling me to square root 5 over 4. Now, the important thing about quadratic equations is that, once again, it can have 2 solutions, 1 or 0. Okay, so whenever you come across quadratic equations, at the end of the square root or at the end of a perfect square, you need to add this plus minus sign. Okay, the reason being is the following. Let's say, for example, I had 9 times 9. 9 times 9 gives me positive 81. Now, if I were to do negative 9 times negative 9, that also gives me positive 81. Now, quadratic equations is the following, right? Where it has two different solutions that gives me the exact same answer. That's why I need to have a plus minus in front of my square roots when I'm dealing with quadratics, as well as in front of like square root of 9, right? That equals me to 3. So in front of that 3 needs to have a plus minus because of this example here. If I were to do -3 times -3, it equals me to positive 9. And positive 3 times positive 3 gives me 9 as well. Okay, there's two solutions for it. All right, so let me just get rid of this. My answer is going to be plus minus square root 5 over 4. I'm not quite done yet, okay? Now I can see this 4 here is a perfect square. So if I square root a perfect square, it gives me a nice whole number. So it'll be equal to, right? I'm just going to break down this square root into 2. So now my fraction looks like this, square root 5 over square root 4. That should give me plus minus square root 5 doesn't give me a whole number, so I'm just going to leave it as is. Over square root 4 gives me 2. So x will equal me to plus minus root 5 over 2. Okay. All right, second question B. Y plus 5 whole squared equal me to 9. All right, I want to get rid of that squared, right? To get rid of that squared, I need to square root it. Square root on both sides. This squared and this squared will cancel out. On the left-hand side, I'm left with y plus 5 equaling me to square root of 9 is 3. But because it's a perfect square, I need to add that plus minus. Okay. Now I want y equal to, so I need to get rid of this 5. So I'll subtract 5 from it on both sides. I'm left with y equal me to plus minus 3 minus 5. Now that plus minus means I have two solutions. So my two solutions can be y equal to 3 minus 5 or -3 minus 5. Okay, so my first solution is going to be -2. So y can be -2 or y can be -3 minus -5, -8. Those are my two solutions. Okay, so question C. 7x squared minus 21x equals to 0. This is where my factorization, my methods of factorization comes in. Okay. All right. So I've got two terms, 7x squared and -21x. I can't use PSF because I'm missing a number here. I don't know what number, let's say 5, right? To use PSF, I need to have three terms. One with an x squared, one with an x, and one with just a number by itself. I can't use that. It's a non-monic, yes. Yeah. There's a number greater than 1 next to the x squared. But again, non-monics mean that there has to have three terms. Okay. So it can't be using grouping in pairs. I can't really use difference between two squares because these numbers here are not perfect squares. Okay. So that means it leaves me up to HCF, highest common factor. So let's look at it here. My highest common factor between 7x squared and minus 21x is going to be 7x. Okay, that's my highest common factor. Now, to know what to put inside the bracket, all I'm going to do is 7x times what gives me 7x squared? Well, 7x times x gives me 7x squared. 7x times what gives me 21x? 3. Okay, so right here, this is me factorizing 7x bracket x minus 3, close the bracket, equals to me to 0. And this here is called the null factor. The reason why I know it's called the null factor is because it has to equal me to 0. the null factor, okay? So something that's been factorized equal to 0, okay? Well, so how I'm going to figure out using the null factor, right? Pretend this part here, this is A, this is B, right? Remember from our null factor at the top here? A and B, okay? So 7x is my A, 7x needs to equal to 0, following my null factor theory, okay? Or B equals to 0, which is x minus 3 equals to 0. Okay, I've got two options. The reason I've got two options is because it's quadratics, first of all, right? So you can have 0, 1, or 2 solutions. In this case, there'll be 2 solutions. And I'll just solve them. So how do I get x from 7x equals to 0? I need to divide this by 7 on both sides. X is going to equal me to 0. So that's one solution. Or x can equal to, I'm going to plus 3 on this side, plus 3 on the other. X equal to 3. Okay. So x can equal either to 0 or x equal to 3. All right, question D. This one here, x squared plus 7x plus 10 equals to 0. I know it's not a non-monic because this number here is just 1, nothing bigger than 1. I can't use difference between two squares because difference between two squares is 2 terms, but they must be perfect squares. Then I can't use that one. I can't use highest common factor because there's nothing in common between the 3 terms. So all I need to do now is use PSF. Okay, so looking at this, the product is going to be positive 10. The sum is going to be 7. What two numbers multiply together to get me 10? When I add them up, gets me 7, 2, and 5. Okay, so I'm going to put it in and factorize that. X and X, and I'll put my factors. Okay, again, this is null factor here. Right here is null factor because it's something equal me to 0. Something factorized equal me to 0. All I'm going to do now is have x plus 2 equals to 0 or x plus 5 equal to 0. Two options. And I'll just solve it. Minus 2 on both sides. First option can be x equal to negative 2 or x can equal me to negative 5. Okay, that's for question D. Lucky last question. 3x squared minus 5x minus 2 equals me to 0. I think you know what the method of factorization here is. First off, the number is greater than 1. That's in front of the x squared, so that means it's straight away grouping in pairs. All right, so using grouping in pairs, that means I need to use two things, PSF and HCF in one. Yeah, so the product here is going to be not just negative 2, but I need to multiply that negative 2 with that 3. So negative 2 times 3 gives me negative 6. The sum needs to equal to negative 5. Okay, what are my factors that I can multiply together to get me 6? But then when I add them, I will get negative 5. Well, it's going to be 1 and 6. And it's going to be negative 6 and a positive 1 if I had to add them together. Remember that manipulation. All right, let's go. 3x squared, using grouping in pairs here. Okay, 3x squared, and I'm going to choose the factor that has a highest common factor with 3x squared. That's going to be 6. So minus 6x. Then I'm going to put plus x, plus 1x minus 2 equal me to 0. This is a pair. So now I'm going to find the highest common factor between that. That is going to be, the highest common factor is 3x, bracket 3x times what gives me 3x squared, x. 3x times what gives me negative 6x minus 2. Plus, I can see here that this is exactly the same as this. So what I'm going to do is, to take as my highest common factor, it's going to be, I'm going to take 1 as the highest common factor, because anything multiplied by 1 gives me the exact same, gives me itself. So 1 bracket x minus 2 equal me to 0. Okay. You're on the right track when the stuff that's in the bracket is exactly the same. I'm going to take x minus 2 as the common factor, and I'm going to put in the rest that is left, so 3x plus 1 in the second bracket. That equals me to 0. Null factor here, so now I'm going to solve it. X can either equal to x minus 2 equal to 0, or 3x plus 1 equal to 0. Okay, simple solving. Okay. This one I shouldn't really have to say too much. So x can equal me to 2, or x can equal me to, let's work it out. Should be, I think, 1/3. There you go. So x can either equal me to 2, or x equal me to negative 1/3. Hopefully this video makes sense. I know it's a long one, but we need to get through it and all those factorizations of methods. So yeah, hopefully it's helpful, and we'll see you in the next one. Bye.